Hi there, you're in the lab with your mate JJ. Today is Interlude. We're doing an interlude today, a little digression. I would do it as an electronics project, except I'm still in the process of doing the old book teardown of electric circuits. I've been working on this for months, and I haven't finished it yet, so I can't do a new electronics project till I finish doing the old book teardown. So I've had to do this video as an interlude, which is all cool. Today we'll be making a cable. I'll tell you more about that in a second. Before I do, I just thought I'd let you know, just recently, in preparing for the new Learning the Art of Electronics project that we're just about to kick off, I've been going through this. I did a new book teardown of Electricity and Magnetism, 3rd edition from Purcell and Moore, and this is a really great book. I've read the whole thing now from cover to cover because I was doing the new book teardown of it, but I I left my microphone on mute while I was recording, so there was no audio. So having done the whole thing, I'm going to have to go and do the whole thing all over again. So stand by for that. It'll be coming out soon. I'll just have to re-record it. So that's one thing that's going on today. I'm actually working through Elliot Williams' AVR programming book. I got it from Make Media a while back, and it's about how to program the AVR line of microcontrollers. They used to come from Atmel, of course, but now that's been purchased by Microchip. So they're the Microchip ATmega and ATtiny microcontrollers. The AVR line, AVR, it's a variant of RISC. So, and RISC, of course, reduced instruction set. Now, what we're doing today is we've got a battery pack here. This is a 4 AAA thing, and we're going to put it on this, and the purpose is to power an ATtiny. So we'll just jump over to the bench together. I'll explain what we're doing, then we'll do it. It's not going to take very long. It's just a good, quick, honest, making a cable project for the channel. So over to the bench we go. Here on the bench. So I've got this ATtiny programmer. It's called the Spark Fun Tiny Programmer. It can program these 8-pin tiny microcontrollers. And then I've got these boards, which are little breakout boards for the ATtiny, called the HW260. These are the HW260 boards. And we can program them with this, and then we can power them with this, and there's a little onboard LED, as I recall. So what we're going to do is, you see on the side here, we've got micro USB power. So we can power this thing off micro USB, but I wanted to program it with a battery. So I've got a battery holder here that will hold 4 AA batteries, which will give us 6 volts in, and it's got a little, I assume it's got a little a power adapter thing. What am I trying to say? Voltage regulator. So if we feed in 6 volts, I'm led to believe that that will work. Now you can see that this battery pack uses the 9-volt power interface. So it's not actually 9 volts, but it uses that power. So I can plug the power in there, and then we run that out. And what we want on the other end of it is micro USB, but I thought rather than put micro USB adapter on here, which I guess would be the most direct thing to do, I thought I might instead put on a female USB-A, and then I can just use a USB-A to micro adapter. This is probably more generally useful, because if I want to, I can use the same thing. I can plug in a mini adapter or a type B adapter So I thought we might just hook this up there, and then we should be able to power everything. So that's what we're going to be doing. I suppose I should show you. I picked this out of my my USB-C box. I've got. Can you see there? Yeah, it says USB Type A female. So in here I've got all different types of oh dear me. Just give me a second while I clean that up, hang on. So yeah, I've just spilt my box of, my bag full of, these are type B females, but they're for mounting on a circuit board. So let's put those back in the box. We won't be needing them. I thought I might use something like this, but I found something better. Put these away. Do that up so I won't have the same problem again later. I have these ones as well, which are just on a little breakout PCB board. I got all sorts of options, but what I found was a bunch of these, just USB-C female, and the 4 wires coming out. So I thought I'd use one of these. I've got 3 of them, so still got some spare. And that's what we'll be doing. We'll be connecting this and this, and there's no need for the data lines. We'll just tie them off. So it'll just be a little bit of soldering, a little bit of heat shrink. We'll snip off these data lines, and then we'll be good. And we'll also need the USB-C, USB-A to USB micro for the actual power. I've put a little red mark on this to indicate to myself something, but I forget what the red mark was to indicate. With any luck, when we power this up, it'll flash a light at us. So yeah, I'll be back in a sec. I'll just go grab a USB Type A to USB micro adapter cable, and that's it there. This is the Type A to micro, so that should go in there like that, and then that can go in here like that, and then we'll be able to plug this in here and do the batteries. So let me grab some batteries. Alright, there's our batteries. So let's put them in. And let's grab our trusty multimeter. Which one will we use? Here's one. So this is my EV blog BM2257. Let's just put it in DC voltage mode, and we'll hook him up that way so we can see him. And we're just going to put this guy on negative and this guy on positive, and we've got 6.2 volts. Wonderful. Let's put him away. So we'll just disconnect this, and I'm just going to throw the old soldering iron on. Should be warming up there. Now I'm going to put some water in my soldering sponge. Now, sizzling, great. I'm just going to unplug this. So we checked the voltage and that's working. Now we're going to need a little bit of heat shrink. So how are we going to do that? I'll just what am I going to do? Tell you what. So this great big honkin' black, that's big, but this stuff looks about right, doesn't it? I don't know if we'd go any smaller than that. Yeah, I'm surprised. I thought I had more heat shrinks around the place. Anyway, let's just snip off a little bit. So here's our snips. And we're just going to need a little bit of red and a little bit of black. It does seem a lot thicker than it needs to be. So let's put that over there and that over there. I've done it so many times I forgot to put the heat shrink on before I did the soldering. I suppose everyone's done that. Now we're just going to clip off the data lines because we don't want them shorting. So that's going to come off there. And I think we can just, there's just a little exposed bit on each end. I think we'll just wrap it around and then solder it up. So just bending them each backwards and then hooking them together. That ought to do the trick. Alright, so I think we could benefit from the third hand here. Let me just put that there. Alright, and just pop him in there. It's good to me. Alright, we're just going to need a little bit of solder, which we've got here. And here we go. A little bit of heat underneath the whole thing. There it goes. Wonderful. So how did we do? Well, it'll probably do. You know what I should have done? I'm gonna redo this. I think we can do better. Let's put him back in there. Just heat him up and disconnect him. I'm gonna get a larger bit. There we go. So I'm just going to get a great big honking bit, and we'll put that over the whole thing after it's done. So let's just pop him through there. Now, just going to snip these off, and then we'll do a bit of wire stripping as well. It's always a good idea to keep the little bits of off-cut wire off your work area so that you don't short out the circuit that you're working on. Now, that looks like about 26 to me. So let's just take a bit off there. There we go. And same again over here. Wonderful. Okay, and I want to do the same on the other side. So we're just stripping off a bit of the insulation here on each side of the connection. Just alright. So again, we're just going to bend it back on itself. And then we're going to hook them together. And we'll stick them in the third hand here. And then we'll just put a blob of solder in there. Yeah. That seemed to work pretty good to me. Yep, that looks good. I'll just pop the heat shrink over the top. Now we're going to do the same for the black pair. We'll just bend him back on each side. And join them together. And then we'll just hook him in there. And a little bit of heat on the joint. Wonderful. Alright. Well, now we'll just put the the heat shrink over each side. And we're going to need our hot air gun here. So we'll just turn him on. Oh, he was already on. Not sure why that's not working. Oh, I don't know. There he goes. So it was just the auto detect function wasn't working properly. Alright, well let's just heat up our heat shrink. Alright, well let's it's all very good, and we'll just put the black one over the top. Just tie the whole thing up. We'll just get our hot air gun again and shrink this bit. Well, that seemed to work pretty well, I think. So, put him back in there. We're done with our third hand for now. Put him away. Now let's see what we've got on this chip, huh? So put the power on, and then plug him in, and maybe he'll flash at us. Who knows? Well, who knows what it's supposed to be doing? It seems to be powered appropriately, and it's all off the power supply there. Great. All right. Well, I'll throw you over to the farewell cam, and we'll wrap up. And that's a wrap. So we've made our cable. You can see the whole assembly here. It's the whole disaster. We've got our battery pack through our 9-volt adapter through to our USB-A female, through to USB-A male, through to micro USB, and then we've got our HW260 board with a ATtiny microprocessor in there, or microcontroller I should say. So yeah, there it is. It's all battery powered and everything, which is great. So I'm going to take this programmer, plug it in over there, program the thing, then plug it in here and watch it work. So isn't that great? I suppose one thing we could have done is put a power switch in the cable so that we could turn it on and off. But I think it's just as easy just to plug and unplug, really, isn't it? So I think that's perfectly fine. So there we go. That concludes this little project. Making a cable, one of our favoritist things to do here on In the Lab with JJ. So stand by for more stuff. I've got all sorts of stuff planning to come out soon, and I haven't forgotten, obviously it's front of mind, is the Learning the Art of Electronics, the first lab course that's going to come out on the first Tuesday of the next month. So I've got to get to making it as soon as I can. I'm going to get on with that soon because I want to be I want to hit those deadlines as they happen. It's going to be the first Tuesday of the month. I have been hoping to receive my second edition of Learning the Art of Electronics, which I pre-ordered on the 10th of January. It's not here yet, so I'm probably going to be doing the first video on the first edition of the book, but I'll switch over to the second edition just as soon as I can. So yeah, that concludes today's video, just making a cable. So I hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe. I thought I might give you a little demo of the cable we just made. So this is my Spark Fun AVR, tiny AVR programmer. You can see it's got an 8-pin dip socket there, and I used it to program this ATtiny85, which is a little integrated circuit you can see there. That's actually an Atmel, or now microchip ATtiny85 microcontroller, and you can see it's powered off the battery pack with the cable that we just made. So that was the purpose of this cable, and it's certainly met its requirements. So yeah, I thought I might show you that. Anyway, enjoy the rest of your day.